Hello, everyone. Welcome to our interview for the South American Mycorrhizal Research Network. My name is Camille Truong, and today I am with Felipe Albornoz, who is the postdoc at CSIRO in Australia, and he is also an adjunct researcher at the University of Western Australia. And Felipe is going to tell us about a recent review paper he wrote in Soil Ecology Letters about revisiting mycorrhizal dogmas. Are mycorrhizas really functioning as they're widely believed to? So, hi, Felipe. Thank you very much for accepting our invitation.
Oh, my pleasure.
Can you tell us a little bit what motivates you to write this review?
Well, it's a commentary, not a review.
Okay.
But it wasn't nearly as exhaustive as it should have been for our review, but we decided to do this commentary because we started experiencing this accumulation of slightly frustrating experiences that, it made us decide to write this commentary just to spark a little bit of discussion around mycorrhizal fungi. For example, we are based here in Perth in southwestern Australia, which is one of the biodiversity hotspots for plant diversity in the world. And yet it's a very under-researched area in comparison to the Northern Hemisphere, especially temperate regions in the Northern Hemisphere. So we started realizing that a lot of the things that we find here don't follow the norm that is found elsewhere, especially in the Northern Hemisphere. Then we started experiencing these slightly frustrating publishing problems that several papers would get rejected because reviewers will refuse to believe that what we find is true because they have these mycorrhizal dogmas, as we name them. As an example, a colleague of mine tried to publish a paper about a cactus from the family Cactaceae that is non-mycorrhizal. Mm-hmm. And it got rejected in the first journal they tried to submit it because the reviewers refused to believe that a cactus wasn't mycorrhizal. Mm-hmm. So that's why we decided to name them dogmas, because they can be blind beliefs, and it's very difficult to get people out of that mindset.
Mm-hmm. So do you think when you talk about this dogma, is it mostly because people believe that several plant families or plant genera belong to certain mycorrhizal type, while the reality is that it may not be the case for all of them? So, but do you think this is something that is really general in all the plants, or is this something that is specific maybe to families that are highly diverse in Australia?
No, that's definitely one of the motivations that we had also to write this commentary, is the generalization that most plant species in the world form mycorrhizal symbiosis. Right? Surely every single mycorrhizal paper you read has the same sentence somewhere in the manuscript.
90%.
90% of plant species in the world, blah, 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 right? But and everybody cites it and repeats it until it becomes a belief, a reality. But if you go to the original papers, the one from Michael Brandrett or Wang and Q, they evaluated over 3,000 plant species. And from those over 3,000 plant species, they show that, yes, most of them, over 90%, form some sort of mycorrhizal associations. But they're very clear in their conclusions that over 90% of the plants studied here form mycorrhizal associations. But somewhere like the telephone game, somewhere down the line of citing this over and over and over, they decided to take this plant studied here, they take it out, and then it became the dogma of most plant species for mycorrhizal symbiosis in the world. But that's not the case. We know the mycorrhizal status of about 1% of all the plant species in the world. So all the 99% is just assumed.
Mm-hmm. Yes.
Based on taxonomy. And the more plants we study, the more exceptions we find.
Yes, exactly. So one example that you give in your publication is that there is a large bias towards temperate northern hemisphere, right? Where there it might be that 90% of plant species form mycorrhizal fungi because this is the regions that are most studied. For example, in orchid mycorrhizae, you explained very well in the commentaries that most orchid species that have been studied, they are terrestrial and they are also from the temperate zone, while actually the highest diversity of orchids are epiphytes and they are from the tropics, right? So
I grab a large proportion of them, yes.
A large proportion of them, yeah. So do you expect to find really different mycorrhizae? What is your hypothesis towards this?
Hypothesis-wise, I'm not sure. The point of this commentary was more about we should not be making bold claims about world distributions or world patterns of mycorrhizal fungi or plant when we simply don't know because we lack information. So we wanted to promote either filling those gaps or toning down those claims. So in this case of orchid mycorrhizal, might as well, they might be doing the exact same thing in the tropics or the epiphytes, but we simply don't know because it's incredibly under-researched. So before we say all orchids are obligate symbionts, maybe we should study at least a lot of the major groups of orchids.
Yeah, that's a really good point.
Yeah, but in terms of my hypothesis, I will say that I would think that the epiphytes are in tropics, they will still form mycorrhizal symbiosis, but I would expect them to either, the epiphytes at least, either develop some sort of coping mechanisms to rely less on orchid mycorrhizal fungi, because the chances of finding a compatible pattern on the trees, it would be way lower than finding fungi in the soil.
Mm-hmm.
So the plant, the orchid, needs to find some sort of mechanism to still live in absence of fungi if fungi is unavailable, or the other way would be forming associations with certain taxa that have developed efficient strategy of dispersion from canopy to canopy rather than through the soil.
Mm-hmm.
But I would expect that there would still be some mycorrhizal association, but at the same time, I wouldn't be surprised if somebody finds an epiphyte orchid that doesn't form any mycorrhizal at all.
Mm-hmm. And what about the Erykoid mycorrhizal fungi? Do you think the same pattern may happen for this group?
Yes, but in this case, I will actually expect a lot more plant species to not form mycorrhizal symbiosis. For example, here in southwestern Australia, there's a great diversity of Erykoid here, but it's also one of the most nutrient-poor soils in the entire world, to the point that phosphorus, for example, is like close to zero.
Mm-hmm.
So mycorrhizal can only work for nutrient acquisition so much. After that, it's no longer a viable nutrient acquisition strategy because the nutrients are in so low abundance, so rare, and in weird forms that they're not readily accessible to plants.
Mm-hmm.
That here, at least, plants tend to shift toward carboxylate release or phosphatate release, like the Proteaceae family.
Mm-hmm.
So I wouldn't be surprised if a lot of Erykoid plants in this region will actually be doing non-mycorrhizal nutrient acquisition strategies rather than Erykoid.
Okay.
Yeah.
Ah, nice. So to go back to one of these dogma, that 90% of plant species form mycorrhizal fungi, the original state is being mycorrhizal, and also some plant species went back to being non-mycorrhizal. For example, some aquatic plants, and that it's kind of rare. So do you think that it's actually not so rare, for example, in these families? And do you think that the original state is necessarily mycorrhizal in these families, and then they lost the mycorrhizal abilities, but not necessarily? Because this is kind of the big dogma also that we have learned in the textbook.
Yeah. I don't know enough to challenge the fact that the origin of like the terrestrial colonization was mycorrhizal. I'm pretty sure that's the case.
Mm-hmm.
And I will agree with the fact that they, in several lineages, they lost the ability to form mycorrhiza, and then they can recover it. Because, for example, the Proteaceae family, it is well established that it's a non-mycorrhizal family.
Mm-hmm.
But not long ago, they found a species of Hakea which is a proteaceae that actually forms mycorrhizal associations, which is very, very weird, very rare. So because of that, I will think that plant species recover the ability to form mycorrhiza rather than everyone else in the proteaceae family lost it.
Yeah, that's a good point. But so the system is probably much more flexible than what we thought.
Yeah, absolutely. Yeah, and that's kind of one of our points, that we should not generalize so much until at least we have more evidence.
Yeah,
because
exactly.
the more species we scrutinize, the more exceptions we find.
Okay, yeah.
For example, for the Cactaceae family, we already are at a 10% of species being non-mycorrhizal.
Non-mycorrhizal. Oh, that's really interesting.
And it keeps going up, keeps going up, keeps going up. So,
yeah. And so, there is a lot of debate about all this, how to define the mycorrhizal type and how many different mycorrhizal types there are. We know about the ectando-mycorrhizal fungi who are from ectomycorrhizal groups, but sometimes they don't show the anatomical structure that are typical from ectomycorrhizal, for example. So what would be your recommendation for the people listening to us about how to apprehend this huge diversity of plants and where to start to fill this gap?
I think the classifications are good in terms of guidelines. That's kind of would be my biggest suggestion and message from this, is that we need to take all this information as guidelines to help us navigate the worlds of mycorrhiza rather than treat them as absolute. So, for example, there is going to be structural morphological variation within arbuscular mycorrhiza or within an Erykoid mycorrhiza. And we also need to accept that there are going to be certain fungi that they're not going to fit the profile.
In the box.
Yeah, so we either create a new category for them, or we just allow them to be flexible instead of forcing them into one of their pre-existing ones.
But do you think, for example, that the molecular studies now that have been done, for example, using metabarcoding of roots, do you think this is also a good way of kind of screening the kind of fungi that you find in the roots? Or it could be misleading because of, and you really need to study the structures as well.
Yeah, I think they are both. Both are very valuable and useful, but they can also be very misleading depending on how the researchers treat the data and draw conclusions from it. It's very useful to know the community of microbes living in a root piece. That's great. That is something that it would be very hard or impossible to do by isolating or pure culturing, because many fungal species just cannot culture. So that's great. But then from that list of species that you have in a root piece, then associating a function to them, that is very dangerous. Saying just because it was an Erykaceae, for example, just assuming that every fungi found in the root piece is Erykoid mycorrhizal fungi, that is simply incorrect.
Yeah, I understand.
So that link between species composition and community and diversity to function needs to be linked with actual experimental assays to prove that all those fungi there are actually Erykoid mycorrhiza and not some other endosymbiont, other endophyte living in the roots.
Yes, that's a very good point. Do you want finally to tell us a little bit more about what you're doing at the moment?
So now I just started a new postdoc at CSIRO, which I'm going to be looking into the use of mycorrhizal fungi, arbuscular mycorrhizal fungi to be exact, into restoring degraded ecosystems. So basically, how can we use mycorrhizal fungi to promote ecosystem recovery in heavily invaded or heavily degraded ecosystems? That's going to be exciting. So I'm going to get to do some applied science into with mycorrhiza. So that's exciting. Yeah.
Nice. Awesome. Yeah. Well, thank you very much, Felipe, for your time.
Yeah, my pleasure.
And we'll be back soon with more interviews for the South American Mycorrhizal Research Network. Bye, everyone.